Hello and welcome to another video. In this video we're going to be working on XOR queries of a subarray. And in this one you're given an array of positive integers and queries. And for each query you want to compute the XOR of every element from the left to the right of the query inclusive. And return an answer where the answer is the answer to the query. So basically they kind of show you here. So for example, they show the binary representations of all these numbers. So 0 to 1 is these two, which is 2. 1 and 2 is these two, which is 7. 0 to 3 is this whole thing, which is, so this would be a 0 bit. This would be 1, 1, 1. So I think it's like 16 or something, 17, 14. Okay. And then this last one is an 8 because it's just this number. And then the second part is basically the same. So essentially, for a query, you just XOR all the numbers in this range. So 2 to 3 would be like 2 to 3, XOR all of these. 1 to 3 would be all these, 0 to 0 would be all this, and so on. And the main thing you want to do when solving these types of problems is recognize, like, okay, if I just brute force these queries, how long will that take? So that's going to be a times q, which is too big, because each of these are 3 times 10 to the 4th, so that's going to be too big. So you can recognize that brute force doesn't work. So then you have to figure out, like, most likely how to speed up your queries. And to speed up the queries in this case, we basically have to figure out what to do. So usually you change the input in some way to speed up your queries. Because, like, yeah. Because basically, yeah, you have some queries, you have to speed them up. It's the only way. Like, you have to go through every query. You can't, there's nothing that you can't speed up, like, going through, like, you can't not go through every query, right? So because I have to go through every query, for that I have to speed up something in the input. And for these, you can basically use a bunch of properties of XOR. And for properties of XOR, honestly, so XOR is probably the most important bit operation you want to know. Like, I don't think in these problems you see, like, a lot of ands or ors, or those are kind of basic. And XOR is, like, the most common one. And XOR is pretty straightforward, and there's a bunch of, like, things that you could do with it. But essentially, one of the properties of XOR is if you have, like, A and B and C, or XOR. So A XOR B XOR C. The order doesn't matter, so this is the same. You know, and you can do this in any way, because XOR, all it does is count up the number of ones in the whole thing. So if I XOR all of these, for examples, for this bit, I just count up the number of ones, and if it's even, it's a 0. If it's 1, it's odd. Same thing for this bit. Same thing for this bit. So the number doesn't matter, or the order doesn't matter. You're basically just counting up the number of ones. So that's one operation. And there's a bunch of other ones. I guess, yeah, another one is like, if A XOR B equals C, then something like this. Not that. C XOR A equals B. That also works. So basically, XOR works kind of like a plus, except for a plus, to reverse it, you minus, and for the reverse of XOR is just XOR again. So that's, like, the reason this works is because, so, like, A XOR A is 0. So for a plus operation, if you have, like, A plus B equals C, then you do A equals C minus B. But if you do A XOR B equals C, and you want to solve for A, you could do C XOR B. So basically, XOR is kind of like the reverse of XOR, if that makes sense. And these are pretty much the main ones. I guess these two are similar, and yeah, just XOR of a number with itself is 0. So if I have a bunch of numbers, this works kind of like a sum. So first of all, let's just think about, imagine if this was a sum, right? Imagine if this wasn't XOR, this was just a sum. And I basically asked, like, okay, given a range, how do I get the sum? Well, you can do that with a prefix sum. So the prefix sum, basically the idea is a prefix sum stores the cumulative total up until and including an index. So if I have some array, like, let's just walk through really quickly that example. So let's say we have this example. So basically at 0, we just have 1. At 1, we have this whole total, which is 4. At 2, we have this whole total, which is 8. And here we have 16. So this is the whole total up and including this index, right? So for 2, this is like, this is these. For 1, this is these. For 0, this is this. For 3, this is whole thing. And if you want the sum of a range, you just say like, well, if I want the sum of like this range to this range, let's say, you know, maybe I want the sum of like this range here, I could just say like, well, I could just take the number here minus the number here, and that would give me that range. So I could just do 16 minus 1 and so on. So if you compute a prefix sum, then you can get these queries if these queries were a sum in O1. And an XOR basically works the same way, except the only difference is the opposite of XOR. Like, as we saw in these other things, to cancel an XOR, you just XOR again, right? Because A XOR A is A. So in a sum, the reverse is subtract. But here, the reverse of an XOR is just XOR again. So we can kind of do the same thing. So we could just say, like, let's just take the XOR sums, or just like XOR of everything. So basically this would be 1. Then this would be 1 XOR 3, which is 2. Then this would be 2 XOR 4, which is 6, I think. And then 6 XOR 8 is 14. Yeah. And then we can kind of do the same thing. So let's do these queries. So basically we can say, well, if we want 0 to 1, if we want this range, we can just take the XOR value at 1. And then remember, so for a prefix sum, we would do a minus, but here we would just do XOR the value right before here. But there's no value right before here because this starts at 0. So basically the XOR of this range is this number here, right? Because the XOR of this whole, like a whole chunk, is just whatever number we have saved. So the XOR of this is just 2. So this first one's 2. Then 1 to 2 is this, which is this thing. Or not minus, XOR whatever comes before it. So 6 XOR 1, which is 7. Yeah. And then 0 to 3 is this whole thing, so that's just this number here, which is 6. And then 3 to 3 is just the last number. Not the last number. 3 to 3 is the last number minus the number before. So it's 14, sorry, not minus, XOR, right? So it's 14 XOR 6, which is 8. So hopefully that makes sense. If this doesn't make sense, the way you could think about it, another way that does make sense is, like I said, XOR is basically just a count of bits. So instead of storing these numbers, you can just store the count of bits at every single bit. So you could store like a dictionary, and this is common for harder XOR problems, where you store a dictionary of like, okay, at the 0 bit we have like, you know, 7 ones. At the 1 bit we have like 8 ones, and so on. So you could store your number in that way, and then now you could just do a straight subtraction to figure out like how many ones are in your range. And then when it's an odd number of ones, that bit is a 1. If it's an even number of ones, that bit is a 0. And then we can figure out what's the value of that bit, right? So this is 2 to the 0, 2 to the 1, whatever other bit we have, and then we can just get a number that way. So that's basically a lot more work, and this is like the shortcut way. But yeah, essentially, you basically have to recognize XOR works exactly the same way as a sum, except the only difference is the reverse of a sum is a subtract, and the reverse of an XOR is just XOR again. And it works literally the same as a prefix sum. So that's what we are going to do. So we'll just code up this prefix sum. You could do this in place, but then you'd have to manipulate the array, so I'm not going to do that. So we're just going to code up a prefix XOR of this array, and then we'll answer our queries in O1. Okay. So first thing, so we want an int array. So basically we want an int array that's the length of this array here. So we could say like int array XORs equals new int array of array. And we could just say like our current total or total XOR or whatever, we'll call total equals 0. We'll go through every single number in the array and fill this out. So 0. And this is just XORs I. Or first we have to update our total. So total, we're going to XOR the current number we're at. I. And then XORs I equals total. Okay, so now we have our prefix XORs, and now we can just use that to answer all our queries in O1. So we have the same thing for the result. And same thing here, except this is not array length, this is queries length. Queries. But yeah, definitely get comfortable using these XOR operations, kind of know how it works, the shortcuts and so on. Because XOR is the most common, and there's a bunch of like properties that it has, some of which are shown. There might be some more, but you can kind of just play around with numbers and figure most of them out. Like I never like read a book on it. I just like, you know, get some numbers, try some operations, and see what works. Okay, and then yeah, so now we can do these basically in O1. So we can just say result I equals. So what we want to do is we want to get first of all, we want to get like the two numbers in the query. So we could say like index equals queries 0. Okay, so we're going to get XORs at Y. So for a prefix sum, you would basically get the prefix sum at this index minus the prefix sum at the index before this one. Because we want to include this one, we don't want to include the one before. So we can have a x equals 0. So if x is 0, that means we're getting the whole thing. That means like we're getting a query from the start, which means we don't have to subtract everything, or we don't have to subtract anything. And sorry, remember this is not a minus, this is an XOR, because the opposite of an XOR is an XOR, not a minus. So if x is 0, then this is just 0 because we're just getting like a whole XOR up to some index from the start. And also a with 0 is a. That's another property of XORs because 0 doesn't change the number of ones in any of the bits, so the bits stay exactly the same. So a with all zeros is a with all ones is a flip of a. Okay, so if x is 0, it's 0. Otherwise, it's XORs x minus 1 because we want the number before x. And that should be it. So yeah, if this is confusing, just play around with these things and it should be pretty clear. Then this is I. Right. Okay. Yeah. So basically we have to go through our whole array. So that's length of array. Let's call that n. We have to go through queries, m. We solve every query in O1. Technically, like I said before, XOR of two numbers is not an O1 operation, but it's close enough because you're basically XORing every bit. So so like if your numbers are up to 10 to the 9th, this might be like, I don't know how many bits are in 10 to the 9th, you know, whatever, it's like 30 or something. So it might be like 30 times n plus m. So it's still basically O1. And then the XORs array, the prefix array is length of the array, so that's like n. And then the result array we're not counting, and everything else is constant. So yeah, I think that is it. Yep. Okay, and yeah, some small things. I'm probably not going to do easy videos unless there's like something interesting in them. You know, if it's like appending two arrays or something, I'm not going to do videos on those because there's like not much to do. So I'll probably just do mediums and hards, and then I might come up with some other stuff to do. But if there are easies that are like, there's like a clever solution or something, then I'll do that. But I don't want to make like a 14-minute video of like introduction to binary trees or that kind of stuff. There's like a lot of stuff out there ready for that. So yeah, thanks for watching, and I'll see you next one.